Okay, welcome back everyone. Today we're going to be covering section 3.3. And remember that last time we were studying how to graph polynomials, and one of the things we saw was that the degree of the polynomial and the sign of its leading coefficient give you the end behavior. That's the behavior of the graph, kind of like out here when x is really big and positive or negative. And then one of the things we wanted to do was to figure out what happens when the graph is near the x-axis. And to do that, we needed to find the zeros. And so the whole motivation for today is finding those zeros. And to do that, you need to factor f of x, which means you need to do some division. So we're going to start off with just the general algorithm for how to do polynomial long division, and then we'll find a faster, sneakier way to do it using synthetic division if you're dividing by a linear factor. So let's get started. So the example 1 says, or asks us to divide 6x to the fourth plus 5x cubed plus 3x minus 5 by 3x squared minus 2x. And the two-step process here says, remember to arrange the terms in descending order, which this is already in descending order. It goes 4, 3, 0, or 1, and 0. And then it says replace any missing powers with a 0. So we got to remember to put 0x squared here at some point. So let me write this down. I have 6x to the fourth plus 5x cubed plus 0x squared plus 3x minus 5. And we want to divide by 3x squared minus 2x. And so we ask ourselves every time here is, what do I need to multiply this leading term, 3x squared, to get 6x to the fourth, for instance? And so the answer in this case is 2x squared. If I multiply by 2x squared, I will get 6x to the fourth. And then 2x squared times negative 2x is minus 4x cubed. Okay, and just like in regular long division, now what we're going to do is we're going to subtract off that whole thing, and so I'd have to change the sign of the negative 4x cubed to be a positive. So I should get 9x to the third when I add 5x to the third plus 4x to the third, and it'll be plus 0x squared. And now I ask the same question again. What do I need to multiply by? What do I need to multiply 3x squared by to get 9x cubed? So that'll be 3x in this case. So 3x times 3x squared is 9x cubed. And then 3x times negative 2x is negative 6x squared. And again, I subtract. So I need to change the signs there. And so now I should get 6x squared plus 3x. And so now to get 6x squared from 3x squared, I multiply by 2. So that should be 2 times 3x squared will give me 6x squared minus 2 times 2x is 4x. Okay, and again, we're subtracting, so I need to flip the signs and add. So I get 7x minus 5. And at this point, we can't multiply 3x squared by anything and get 7x. So this is our remainder. Okay, so this is a remainder of 7x minus 5. And so what we figured out is that we can factor 6x to the fourth plus 5x cubed plus 3x minus 5, or we can write it as 2x squared plus 3x plus 2 times 3x squared minus 2x plus the remainder. Let me put this here. Plus the remainder, which was 7x minus 5 Okay, so this is the conclusion, is that we can write 6x to the fourth plus 5x cubed plus 3x minus 5 as the product of 3x squared minus 2x times 2x squared plus 3x plus 2 plus the remainder of 7x minus 5. Okay, now I want to show you synthetic division, which is just a faster way. There's less writing, but it's the same process. It's a faster way to do long division if you're dividing by a linear factor, and by that I mean something of the form x minus c. So the algorithm goes something like this. I'm going to write down, you have x to the fifth, and then you're going to have plus 4x to the fourth, plus an x cubed, but there's 0x cubed, and then an x squared, and then an x, and then a constant term. So let me put it like that. Okay, so what you're going to do is you're going to write down the coefficient here. So we have 1 times x to the fifth plus 4x to the fourth plus 0x cubed minus 3x squared plus 2x plus 3. Okay, so you write those down and you put like a blank line and then put a little black line or something underneath that. And then you take the opposite of the 3. So instead of being x minus 3, you put positive 3 over here on the right. Okay, so that's how you set up a synthetic division problem. And now what you're going to do is you're just going to always well, first you start off by bringing this constant down, so the 1 just comes straight down and becomes 1 down here. And then you multiply by the 3. So 1 times 3 is 3. And now you add. So this is going to be 4 plus 3 is 7. Okay, so the nice thing about this is you don't have to worry about really changing signs. You just multiply and then add. 3 times 7 is 21. 0 plus 21 is 21. Okay, 3 times 21 is 63. And then negative 3 plus 63 is 60. And then 3 times 60 is 180. And then 180 plus 2 is 182. And then 3 times 182 is a really big number. Let's see, what would that be? 3 times... So 246 plus another 300, I think it's 546. Okay, so 546 plus 3 is 549. Okay, so what has that told us? Well, the 549 will be the remainder. And I shift down by the powers here. So instead of an x to the fifth, I'll have an x to the fourth, an x to the third, an x squared, an x to the 1, and then an x to the 0 or 1 power, right? Okay, so what this told me is that x to the fifth plus 4x to the fourth plus 0x cubed minus 3x squared plus 2x plus 3 can be written as the following. It can be written as, let's see, x minus 3, which was our linear factor, times x to the fourth plus 7x cubed plus 21x squared plus 60x plus 182, but then I'm going to have a remainder of 549. Okay, so again, this right here is your remainder. So again, this is the conclusion. So when you're doing long division, you're really factoring in a way, or trying to factor. And you might get a remainder, which means that the thing didn't factor perfectly. Okay, now I'm going to shrink this up because I want to make one more statement here. So I'll shrink this a little bit and move it over. Okay, so the first conclusion was that we could factor this equation and get that statement. But if you divide both sides by x minus 3, then this is equivalent to saying that x to the 5th plus 4x to the 4th minus 3x squared plus 2x plus 3. If I divide by the green thing, x minus 3, I get the blue thing, which is x to the 4th plus 7x cubed plus 21x squared plus 60x plus 182 plus my remainder, 549 over x minus 3. So you might have seen the remainder written like this. And it's the same statement, right? You're just taking what's in the black box and dividing both sides by x minus 3. Okay, so either one of those is fine. Now what I'd like you to do is to take a second and do problem 1 on your own. You're going to have to answer a quiz question through Kaltura or on Canvas. So you do this problem, report back your answer, and then I'll show you how to do it. But this is just like the preceding problem or example, so you should be able to do it pretty easily. Okay, so now to check your work, we write down our x cubed, the x squared, the x, and the x to the 0 or the constant. And I put the coefficients, so this is 1, 6, negative 11, and 6. And remember I'm going to do 2 because I want to take the opposite sign of whatever's in there. And then I leave a line. Okay. So now I start off by bringing the first thing down, and I get 1, then 2 times 1 is 2, 6 plus 2 is 8, so I'll leave these in black. So I have 8, 2 times 8 is 16, and then a negative 11 plus 16 is 5, and then 2 times 5 is 10, so 6 plus 10 is 16. So this has told me is that I can write this as x to the, or 1x squared plus 8x plus 5x to the 0, and then I'll have a remainder of 16. So x to the 3rd plus 6x squared minus 11x minus 6 is equal to x minus 2 times what I just found out, which was x squared plus 8x plus 5, and then plus a remainder of 16. Okay, and so you might be wondering, like, what's the big deal about finding this remainder? Hi. Okay, so if you look back at problem 1, you might be wondering, like, what's the big deal? Why are we doing this whole process? Well, the remainder theorem says that if you divide by the polynomial by x minus c, then the remainder is what you would have gotten if you plugged in c. So like in the previous problem, since we divided by x minus 2, what this is telling us is that if we plug in 2, then the remainder is that polynomial evaluated at 2. So let me just quickly show you what I mean by that. If you're plugging in 2 here to this polynomial, you could go through the process of plugging it in over here. You'd have to plug in and do 2 cubed plus 6 times 2 squared minus 11 times 2 minus 6. Or if you've already done the factorization, then what you see is that if you plug in 2 into this first part, you get 2 minus 2, right? So that's going to be 0. And then you have, you could plug in 2 over here, but it doesn't matter because you already have 0 times that whole red thing. So all you really got left over is this 16, right? So the remainder is exactly f of c. So if this is f of x, then we know that f of 2 has to be the remainder because you're going to get 2 minus 2 in that first factor. Okay, so that's one of the main reasons why you'd want to do this, is to actually figure out what you get when you evaluate at C. Okay, so that's the remainder theorem. So what we want to do is we want to use the remainder theorem to find f of 2. So the goal here is to find f of 2. And one way to do that is to use synthetic division and for 2. So I'm going to go through that whole synthetic division process again. You're going to end up doing this a lot over the next week or two. So I'm going to have an x cubed term, an x squared term, an x term, and an x to the 0 term. So I have 2, -7, 7, and -6. And I'm plugging in, I'm evaluating it at 2, so I want to put the 2 there. Okay, so again, we do this whole process again. Bring the 2 down, 2 times 2 is 4. And then 4 plus -7 is -3. 2 times -3 is -6. 7 plus -6 is 1. 2 times 1 is 2 times 1 is 2. -6 plus 2 is -4. So remember that this is the remainder. And so what we found is that f of 2 equals -4. Okay? And again, that's because, that's because what we've just done when doing synthetic division is we've written f of x as x minus 2 times 2x squared minus 3x plus 1 plus our remainder of -4. Right? So this is 2x squared minus 3x plus 1. That's what this is telling us here. Plus the remainder of -4. Cool? Okay. Again, I'm going to have you try and do problem 2 on your own. It's just like the previous problem. Actually, it's exactly the previous problem, so I'll have to fix that in a second. Okay, now what I want you to do is to do problem 2 here, which is to find f of 3, where f of x is x cubed minus 6x squared plus 11x minus 6, by using the remainder theorem. So I'm going to let you pause and answer this question, and then I'll show you how to do it in a minute. Okay. So let's see how to do this. So again, I'm going to write x cubed, x squared, x, and x to the 0. So the coefficients are 1, -6, 11, and -6. And I'm evaluating at 3, so I need to put a 3 there. Okay, so we bring the 1 down. 3 times 1 is 3. -6 plus 3 is -3. 3 times -3 is -9. 11 minus 9 is 2. 3 times 2 is 6. And look, I got a remainder of 0. Okay, so what does that tell me? The conclusion here is that f of x can be written as x minus 3 times x squared minus 3x plus 2 plus a remainder of 0. Okay, this is my remainder. Again, this was x squared, x, and x0, because you have to shift the powers. This is the remainder part. Okay, so since we've been able to factor it like this, what we found is that f of 3 is 3 minus 3 times this 3 squared minus 3 times 3 plus 2 plus a remainder of 0. Well, this is 0, so we have 0 times some number, so who cares what that is, plus 0. So that told us that f evaluated at 3 equals 0. Okay? And that's actually what the factor theorem says. It says that if f of c is equal to 0, then x minus c must be a factor of f of x, like a perfect factor. Your remainder is 0 there. okay? So we can use synthetic division to find all the factors of an equation, or of a polynomial. And so that's what we're going to do in this last example. We're asked to solve the equation 2x cubed minus 3x squared minus 11x plus 6 equals 0 by finding all the factors. Okay, so we're given that 3 is a 0 of f of x. Okay, and then we'll just keep factoring from there. So let me write down, I have the x cubed, the x squared, and I always do this just so I have placeholders. Right? So I need to put down the coefficients 2, negative 3, negative 11, and 6. And I was told that 3 is a 0. So I know that I'm doing synthetic division by 3 here. And so now I bring the 2 down. 3 times 2 is 6. Negative 3 plus 6 is 3. 3 times 3 is 9. Negative 11 plus 9 is 2. 3 times 2 is, this is negative 2. 3 times negative 2 is negative 6, and my remainder is 0. So I have 2x squared plus 3x minus 2x to the 0 plus a remainder of 0. So what we've just done is we factored that 2x cubed minus 3x squared minus 11x plus 6. We factored it as 2x squared plus 3x minus 2, and we factored out x minus 3 at this point. Okay, so we factored f of x, we've gotten one linear factor, now we're going to do it again. And so we have to try and factor the 2x squared plus 3x minus 2, and now it's anybody's guess what a root would be. So you just kind of have to check things. So we can either try 1, minus 1, 1 or 2, I guess. So you're basically your only options here. So let's try 1. It may or may not work, but that's the best I can tell you, is that you have to kind of guess and check at this point. So let's try it. 2 times 1 is 2. 3 plus 2 is 5. 1 times 5 is 3. Oh, I'd get a remainder of negative 3, so that didn't work. So now let's go back and try something else. Let me try 2. So do the same thing. 2 times 2 is 4. 3 plus 4 is 7. 2 times 7 is 14. I'd get a remainder of negative 12, so that didn't work either. Let me try negative 2. Let's see if that makes things any better. So bring the 2 down, so I get negative 4, negative 1, negative 2 times negative 1 is positive 2. Yes, okay, I finally got a remainder of 0 here. So now I have 2x minus 1 plus a remainder of 0. So what did that tell me? It told me that I can factor this as 2x minus 1 times x plus 2, because it's x minus negative 2, times x minus 3. And again, it's a little annoying that we had to do some guess and check, but this whole synthetic division process is so fast that it's not that bad. And now we've actually factored this whole polynomial, so we know exactly where the zeros are. So again, the application here is that if you need to graph 2x cubed minus 3x squared minus 11x plus 6, well, you can use the leading coefficient or the leading term analysis to figure out that this is going to have n behavior. It looks like this because we have a positive coefficient and degree 3. And then to figure out where it passes through the origin, we know it's going, or through the x-axis, it passes through at x equals positive 3. So x equals positive 3 is going to be a root. X equals negative 2 is going to be a root. Okay, this is telling me that x equals negative 2 is a root. This tells me that x equals positive 3 is a root. And this last one tells me that x equals 1/2 will also be a root. And all of them have multiplicity 1. So this means that I'm going to pass through each time. So this must come up, and then go down, and then go back through. Okay, so this is what y equals f of x must look like. And finally, notice that this is an equivalent way of asking the same question. Use synthetic division to divide this polynomial f of x equals 2x cubed minus 3x squared minus 11x plus 6 by x minus 3. And then use that result to find all the zeros of f. So we found all the zeros of f. Okay, and that's all there is for today. You're going to see that for the rest of this class, we'll pretty much only be covering one section a day, so the video lectures will be even shorter than they have been at the start of the semester.